Unit 5, Day 4, Evaluating Functions. As our warm-up, we have two questions to answer. The first, which table represents y as a function of x? So we can think of functions as in two different ways. One, every x has exactly one y. Every x is exactly one y. Or, if you'd rather think of it with tables, the x's do not repeat. So we are looking for either x's not repeating or all the x's having one y value. So let us look at f. -5 goes to -5. Now if we look down here, it also goes to +5. So the -5 repeats. This one's not a function. Not a function. G. Let's see. 6 goes to -6. -6 goes to 6. No problem there. That x still has one y. 8 goes to -8. -8 goes to 8. There are no issues here. So I'm going to hold on to that one and check out h. Okay, we see here -3 goes to -4, but then -3 also goes to 4. That is not a function. J, 2 goes to -2, 2 goes to -2, to -1, -2, 2 goes to -3, and 2 goes to -4. That one is definitely not a function because that one x value is going 4 different places. Not a function, and therefore G is a function, and is our answer. Now, number 2, you're going to have to do this one on your own. Okay, so if you're watching this at home, pause the video, try it, or in class, pause it, try it. Seriously, do that. Okay, now that you have hopefully tried that on your own, there's the answer. Y equals 13.57x plus 122.14, and this is rounding to the hundredths place. And our correlation coefficient is 0.996. All right, on to our notes. So our job today is going to be to identify independent and dependent variables, as well as write equations in function notation and evaluate a function for given input values. Now that we know what a function is, we're going to use it. So a function, it goes from inputs to outputs, and these are words you'll see. X's, inputs, domain, independent. Output is y, or the range, or dependent. These words are all synonymous. Okay, and our function takes the inputs. They go in, and they come out as a different number. So an algebraic expression that defines a function is a function rule. Look at a few of these. So number 1, chips cost $3 per bag. First, we need to define a variable for the number of bags of chips and the total cost. I'm going to go with the number of bags of chips. I'm going to go with that as an input, okay, x, because it actually gives us the total cost. So I'm going with the total cost. I'm going to use y for that. So numbers of bags of chips. I'm going to go with 1 bag of chips, 2, 3, 4, and 5. Okay, now what is the process to find the cost? $3 a bag. So that would be 3 times 1 bag would give us $3. 3 times 2 bags gives us $6. 3 times $3 gives us 9, etc. 3 times 4, 3 times 5, so we get 12 and 15. Now the process is what tells us our function rule. Okay, our function rule, we see that if we take our number of bags of chips times 3, that gives us our total cost. So our function is going to be y equals 3x. Now based on that function rule, how much money would you pay for 8 bags of chips? Well, we would take y equals 3 times 8 and get 24. So the answer is $24 is how much you would pay for 8 bags of chips. Part B, based on that function rule, how many bags of chips could you purchase with $30? So instead of plugging in where x is, we're going to replace y. So that's 30 equals 3x. Dividing by 3, you get that x equals 10. But that is not what it asked. It asked how many bags of chips. So the answer is 10 bags. Okay. Function notation. In function notation, f of x is used in place of y. The dependent variable is a function of the independent variable, which we have done before. So y is a function of x, you can write that as y is equals a function f of x. So y equals f of x. So to write this in function notation, we simply replace y with f of x. F of x equals x plus 1. So you replace your y with f of x. Similarly, to write f of x equals 3x minus 7 as an equation, replace our f of x with y. And there we have it. Now we are going to use function notation quite a bit. Alright, so evaluate. So number 2 says evaluate y equals 3x plus 1 for x equals 5. So we are going to replace x with 5. So y equals 3 times 5 plus 1, which is 16. So our answer is 16. Number 3, we're evaluating for x equals negative 3. So we have f of x equals, and to be totally accurate, I should probably write this. The x is negative 3, so f of negative 3 equals the square root of 13 minus negative 3. Notice the two subtraction signs. We have minus and a negative. So this is 16. We could just type this in the calculator, but that is 16. The square root of 16 is 4. Number 4, replace t in this case. So instead of an x, we have g of t. So we'll replace that with negative 2. So we get 2 times negative 2 minus 4. I like to draw little blanks for that. We're replacing it. And so if you replace that with negative 2, you get 2 times negative 6, or negative 12. So g of negative 2 is negative 12. Number 5, we're going to do the same thing. We have h of 2 equals 4 divided by 6 minus 2. Replacing that same number there. So that is 4 divided by 4, which is 1. So our answer, h of 2 equals 1. All right, with number 6, starting here for the next couple of these, we are actually given a domain. So domain is another word for the x's, our inputs. And we're supposed to find the range. So we have to actually replace not just one number, but replace 3. So the first time we do this, we're going to do this 3 times. So first I'm going to find f of negative 1. Second, f of 2. Second and third, f of 3. So for the first one, it's going to be negative 1, notice the parentheses, squared, plus 4 times negative 1. Now, if you plug that into your calculator, you should get negative 3. Now, if you plug 2 in, you should get 2 squared plus 4 times 2, which is 12. And if you plug 3 in, you should get 3 squared plus 4 times 3, and so you should get 21. So our range is a list of values. Our range, the values are the values negative 3, comma, 12, comma, 21. That is our range. So doing this is just saying shorthand for do it 3 times. Okay. Number 7. We are given the same domain. Okay, so the domain is negative 1, 2, and 3. We're going to assume that. So we're going to plug in negative 1. So that is, so h of negative 1 is 3 times negative 1 squared minus 7 times negative 1 plus 1. And if you type that in your calculator correctly, you should get 11. So there's our first range value, 11. H of 2, we have 3 times 2 squared minus 7 times 2 plus 1. If you plug that in, you should get negative 1. And I hope that you're pausing this video to check these, because don't just trust my arithmetic. Okay? You want to be able to do this on your own later. So try it now that you can check your answers. And third, h of 3 is 3 times 3 squared minus 7 times 3 plus 1. That should be positive 7. So our range values are 11, comma, negative 1, comma, 7. And there will be our range. Right, we're going to do the same thing for number 8, except we have m of s equals negative s cubed. So our domain is still 1, comma 2, comma 3. So we'll have m of negative 1 is negative, notice that negative already, negative 1 cubed. And that comes out to be positive 1. Next, we take 2, m of 2, which is negative 2 cubed. Make sure you have those parentheses in the right place. That should be negative 8. So our list up here is positive 1, negative 8, and then m of 3 is negative 3 cubed, which is negative 27. So our answer is, our range is positive 1, negative 8, and negative 27 in those curly braces. Okay. Not too bad, I don't believe. Number 9 says the volume V of a sphere with radius r is given by the function V of r equals 4/3 pi r cubed. Find V of 6, and then explain what V of 6 means. Alright, so V of 6 is going to be, V of 6 is 4/3 pi times 6 cubed. 4/3 times, and we're not going to use 3.14 if there's actually a button in the calculator to pull up pi. So pi times 6 to the 3rd power. That is 904, so V of 6 equals 904.779, and by default we're rounding there because pi is an irrational number. It keeps going and going and going and going. Yeah, I've definitely rounded that, so we're gonna say this instead. Instead of saying that equals that, I'm going to say that it's approximately, because it is something close to that, but it's not quite. Now explain what V of 6 means. Well, what is V? V is the volume of a sphere with radius r. So we're actually going to state that again. It is the volume of a sphere with a radius of 6. It's the volume of a sphere with a radius of 6. Okay. Number 15. Given g of x graphed. That's it right over here. Okay. Find g of 2. Well, this is a little bit different from what we've had already. 2 is the x value. So where x is 2, so that's 1, 2, if we look how high that graph is, you have this point right here. It's actually, if you trace that over, that is at 2. So g of 2 equals 2. G of negative 4, we're going to go to negative 4, so 1, 2, 3, 4, and if we trace it up, we have this point right here, and that is at 1, 2, 3. That is at 3, so g of negative 4 is 3. G of 0. Okay, so that means x is 0. So we're going to look at this point right here at 0, go up till we hit our graph, and how high is that right there? 1, 2, 3, 4, 5, 6. G of 0 equals 6. Alright, now part B says find x so that g of x equals negative 1, g of x equals 6, and g of x equals 9. So for this, we're going to be going the opposite direction. Start with a y value, so how high it is at. So let's start at negative 1. We'll find until we hit our graph, and whatever that x is. Whatever that x is right there, which that is 1, 2, 3, 4, 5, 6. So here x equals 6. By the way, this means the point 6, negative 1 is on our graph. Second one there, g of x equals 6. Let's see if I can take, actually I'm going to go and erase all of this so I can use different colors. All right, so g of x equals 6. It means we're going to start at 6 up on the graph. So that's 1, 2, 3, 4, 5, 6. All right, so one place is actually here at 0. X equals 0. But also over here, it's at 6. So that would be at, hold on, that's 1, 2, 3, 4. X equals 4. And actually there are two other places. There's at negative 5.5 and negative 6.5. It only says find one, so really any of those that you find will work. And then if you look for where it's 9, if you look at your graph, it's at 6, 7, 8, 9. And it doesn't look like, as far as I can see, that it actually gets there. So this last one is going to be no solution, or something to that effect. It does not exist. So that one was a little tricky, so we may need to go over that one together as a class. All right, now number 16 says, if m of x equals x squared minus 11, and n of x equals parentheses 11 minus x parentheses squared, which statement is true? So you're actually going to have to do that evaluating thing multiple times here. So first, take negative 2 and plug it in for x. In this function, you should get negative 7. And this is one of those you should do on your own. Now plug negative 2 into this function, and you should get 169. 169. So that certainly does not equal, so A is not it. B, you'll plug in 0 into m of x, and there you get negative 11. Plug in 1 into n of x, and you get 100. That doesn't match. Answer choice C. Plug in 6 for m of x. You should get 25. Plug in 25 into n of x. You should get 196. That does not match. We've already found m of 6, actually. It's 25. And n of 6, if we plug that in, we should get 25, which those two do, in fact, match. Okay, now you might want to spend some time looking at these last two because, like I said, there's a lot in there and it's a little different than what we had before. So for my random math fact of today, I would like to introduce you to something called the liar paradox. It says, I am a liar. I am a liar. Now if I say that, I am both telling, actually you can look at it two ways, I am neither lying to you, nor am I telling you the truth. Because if I'm a liar, then I've actually told you the truth right here. So if I am a liar, then I've just told you the truth, which doesn't make much sense. Or if I'm a liar, then what this is actually saying is that I told you the truth. What happens there? It's a paradox. It's something that we can't really explain, and they actually came up with more rules of math that go with logic to prevent things like this. That's about the liar paradox. The liar paradox. Called the paradox because it doesn't make a lot of sense. All right, so join us next time, or tune in next time for domain and range.